Namaste students. In the last class we were studying about inverse of a square matrix. You know, if A is a square matrix of order n, if there exists another square matrix B such that AB is equal to BA is equal to I, then B is said to be the inverse of A and it is denoted by A inverse. And we have discussed about adjoint of a square matrix. Adjoint of a square matrix is defined as the transpose of the matrix of the cofactors. You know, we can find out the adjoint of 2 cross 2 directly by interchanging the diagonal elements and changing the signs of the other elements. We have studied that A into adjoint A is equal to adjoint A into A is equal to determinant A into I. That is one of the important properties which we have proved that is very important to find the inverse of a square matrix. And afterwards you have studied about singular matrix. A square matrix A is said to be singular if determinant A is equal to 0. A square matrix A is said to be non-singular if determinant A is not equal to 0. Suppose if A and B are non-singular matrices, then AB and BA are also non-singular matrices. We have studied about this and we have understood the property that determinant of product of two matrices is always equal to product of the determinants. That is, determinant AB is equal to determinant A into determinant B, which we have studied. And afterwards, we have studied that a matrix A is said to be invertible if and only if that A is non-singular. That is, if a matrix A is invertible, then A is non-singular. Conversely, if A is non-singular, then A is invertible. We have proved that property, using which we have proved A inverse is equal to 1 by determinant A into adjoint of A. That is the formula used to find out the inverse of a square matrix, which we have studied, based on which we have solved few problems. You know, determinant of A inverse is always equal to 1 by determinant A. We have proved it in the last class. And remember, only singular and non-singular matrices have inverse. A singular matrix does not have any inverse. And remember always, if A is the inverse of B, then B should be the inverse of A. And afterwards we have told that inverse of a square matrix is always unique. And afterwards we have told you important property, that is reversal law of inverses. AB, the whole inverse, is equal to B inverse into A inverse. In the last class we have started with the exercise 4.5, in which we have found the adjoint of a square matrix, 2 cross 2 matrix and also 3 cross 3 matrix, and we have proved that A into adjoint A is equal to adjoint A into A is equal to determinant A into I. And afterwards I have solved 2 problems on inverse of a matrix, and 3 problems I have given you as homework, 3 cross 3 matrices. I think you have solved those problems. Again, we will do one more problem on finding the inverse of a square matrix. Okay, let us consider the next problem. The problem is problem number 11. Let us consider the matrix A 1 0 0 0 cos alpha sin alpha, further 0 sin alpha and minus cos alpha. This is for the matrix. You are expected to find out the inverse of this. How to find out the inverse? Let us write the formula. A inverse is 1 by determinant A into adjoint of A. Let us find out determinant A first, because you know the reason why we have to find out the determinant. If you find out the determinant, if we get it as 0, then we conclude it is singular. It is, the inverse does not exist. Now evaluate either using first row or first column. 1 into, it is minus cos squared alpha minus sin squared alpha minus 0 plus 0. What is the answer? Minus of cos squared alpha plus sin squared alpha you get. So what is determinant A? Determinant A is minus 1, not equal to 0. I think you have understood this. Let us find out the cofactor of each element. Let us take up A11. What is A11? So leave the row and column in which the element is present. Sign is plus, minus cos squared alpha minus sin squared alpha. Answer is minus of cos squared alpha plus sin squared alpha, it is 1. Let us find out A12, the cofactor of 0. Leave that row and column. 0 sin alpha, 0 minus cos alpha. Minus of 0 minus 0, you get 0. Let us find out A13, sin is plus. For 0, leave that row and column. 0 cos alpha, 0 sin alpha. 0 minus 0, you get 0. Let us find out A21. What is A21 now? A21 is the cofactor of second row first column for this 0. You leave that row and column. 0, 0 sin alpha minus cos alpha. Minus of 0 minus 0, we get 0. You take up A22, cofactor of A22 for cos alpha. Leave that row and column. 1, 0, 0 minus cos alpha, you get. It is minus cos alpha minus 0. Answer is minus cos alpha. To take up A23, it's minus for this element. Leave that row and column. 1, 0, 0 sin alpha minus 0. It is sin alpha minus 0, which is equal to minus sin alpha. Let us find out A31. So cofactor of third row first column for this 0. Leave that row and column. 0, 0 cos alpha sin alpha. 0 minus 0, we get 0. You find out A32, the cofactor of sin alpha. Sin is negative. Leave that row and column. Leave that row and column. 1, 0, 0 sin alpha. Value is sin alpha minus 0. What is the answer? You get minus sin alpha. Further, you find out A33, cofactor of minus cos alpha. Sin is positive. Leave that row and column. You get 1, 0, 0 cos alpha. You will be getting cos alpha minus 0. So answer is cos alpha. Think you have understood how we have got this. So what is cofactor of the matrix A now? Please write it in order. Don't miss any of the elements. Minus 1, 0, 0. Second row, 0 minus cos alpha minus sin alpha. Then third row, 0 minus sin alpha cos alpha. That implies what is the adjoint? Adjoint A is the transpose of the matrix of cofactors. You take the transpose. Minus 1, 0, 0. Then 0 minus cos alpha minus sin alpha. Then 0 minus sin alpha cos alpha. Now, what is A inverse? A inverse is 1 by determinant A into adjoint A. What is 1 by determinant A? Determinant A is minus 1 into minus 1, 0, 0. 0 minus cos alpha minus sin alpha. 0 minus sin alpha cos alpha. You multiply that. A inverse is given by minus 1, 0, 0. Minus 1 into 0, 0. It is cos alpha. It's sin alpha. 0. It's minus sin alpha. It's minus cos alpha. This is what A inverse is. I think you have understood how to find out the inverse here. So find out the cofactor of each and every element. Then form the cofactor matrix. Find out adjoint A. It is formed by transpose of matrix of cofactors. Then find out A inverse. Minus 1, 0, 0. 0 minus cos alpha minus sin alpha. 0 minus sin alpha cos alpha. A inverse is 1 by determinant A into adjoint A. 1 by minus 1. So whole thing you multiply through minus 1, you will be getting A inverse. I think you have understood this problem. Please concentrate carefully. That's very, very important. I move on to the next one. It is given 12th problem. Given A is equal to 3725. B is equal to 6879. Verify that, or we can say that prove that AB whole inverse is equal to B inverse into A inverse. This is what to be proved. So look at the problem. A is given 3725 and B is 6879. You have to verify that AB whole inverse is equal to B inverse into A inverse. Let us find out AB inverse first. I write to find AB whole inverse. To find out AB now, A is 3725, B is 6879. So what happens now? When you take the product AB, 3 6s are, it is 18 plus 7 7s are 49. Let us write it here itself. 18 plus 49. 8 3s are 24, 7 9s are 63, 2 6s are 12 plus 35. Now 2 8s are 16 plus 9 5s are 45. So find out the answer here. 67, it is 87, 35 into 25 plus 12, it is 47, 45 plus 16 is 61. That's what AB is. Now you have to find out AB inverse. So AB inverse is got by 1 by determinant AB into adjoint of AB. This is what the formula is. So let us find out determinant AB. What is determinant AB? 67 into 61 minus 87 into 47. You need to calculate what is AB. Find out what is AB. Find out what is AB. 67, 87, 47, 61. Find the value of determinant AB. Find out the adjoint of AB. Find out the adjoint of AB. Find out determinant AB. 67 into 61. Find out 67 into 61. What is the answer you have got? Determinant AB. Determinant AB will be, what is 67 into 61? It's 4087 minus, find out what is 87 into 47. 87 into 47. Find out 87 into 47. Find out 87 into 47. You have to do it. Find out the value. 87 into 47. 87 into 47 you have to find. That is 4089. 4089. So what is the difference you get? Minus 2. Determinant. How to find out the adjoint of 2 cross 2 directly? Interchange the diagonal element 61, 67. Change the signs of the other element. Minus 87, minus 47. This is what AB whole inverse is. You need to have understood this. Let us find out B inverse. What is B inverse? 1 by determinant B into adjoint of B. What is determinant B? Find out determinant B. 9 6 are. So 63. 63 minus 56. 63 minus 56 you get. Determinant B. 9 6 are you have to take. 9 6 are it is 54. And 8 7s are 56. You get minus 2. So it is minus 2 into, find out the adjoint B, interchange the diagonal elements, change the signs of the other elements, minus 8, minus 7. This is what B inverse. Find out A inverse 1 by determinant A into adjoint of A. What is determinant A now? Determinant A. 15 minus 14, it is equal to 1. And what is adjoint A? Adjoint A, interchange the diagonal elements, change the signs of the other elements. Minus 7, minus 2. I think now we have understood how we have done it directly. This is taken as equation 1. Now you take up B inverse into A inverse. What is B inverse? 5 minus 7 minus 2, 3. 1 by minus 2 into 9 minus 8 minus 7, 6. Now I take minus 1 by 2 outside. 5 9s are 45 plus 7 7s are 49. Now you better take 5 9s are 45 plus 49. Then first you have to take B inverse. So first you have to take B inverse. What is B inverse now? Minus 1 by 2 into B inverse is 9 minus 8 minus 7, 6. What is A inverse? 5 minus 7 minus 2, 3. So you take the product, minus 1 by 2 into 45 plus 16 you get. Again minus 63 minus 24 minus 35 minus 12, then 49 plus 18. What we are getting now? Minus 1 by 2 into 45 plus 60, 16, 61, minus 63 minus 24, it is minus 87, minus 47, then 49 plus 18, it is 67. So we get B inverse into A inverse as minus 1 by 2 into 61 minus 87 minus 47, 67, all is as equation 2. So we get equation 1 is equal to equation 2, hence we write AB whole inverse is equal to B inverse into A inverse. So see here, you have to write the cofactor of each element, but I have written this directly, okay? But in the examination you have to write all the cofactors in detail and then write the A inverse. I have done it in a shortcut method. I have formed 2 cross 2, the adjoint of 2 cross 2 directly by interchanging the diagonal elements and changing the signs of the other elements. I take up next problem, 13th problem. It is given A is equal to 3, 1 minus 1, 2. Prove that A square minus 5A plus 7I is equal to 0. That is null matrix. Hence find A inverse. Hence find A inverse. That's what requires. So 3, 1 minus 1, 2. Let us find out A square. It is A into A. 3, 1 minus 1, 2. 3, 1 minus 1. So what happens now? 9 minus 1. 3 plus 2. Minus 3 minus 2. Minus 1 plus 4. What we have got now? 8, 5, minus 5, 3. This is what A square is. What is 5A now? 5 into A. 3, 1 minus 1, 2. What is that? 15, 5, minus 5, it is 10. What is 7I? 7 into I, 1, 0, 0, 1. Answer is 7, 0, 0, 7. So let us consider LHS here. LHS, A square minus 5A plus 7A. What is A square now? A square we have got 8, 5 minus 5, 3. What is 5A? 5A is 15, 5 minus 5, 10. What is 7I? 7, 0, 0, 7. We will be getting 8 minus 15 plus 7, 0. 5 minus 5 plus 5, 0. minus 5, minus of minus, plus 5, minus 5 plus 5 is 0, 3 minus 10 plus 7, it is equal to 0. Answer is O, null matrix, that's what it is. That is the first part. This you have done in matrix chapter itself. Now you have to find out A inverse using that equation. See, this is a special method. A squared minus 7A plus 5A plus 7I is equal to 0. This equation is called characteristic equation of the given matrix. That equation. How to find out inverse? Multiply both sides by A inverse. A square into A inverse minus 5A into A inverse, 7I into A inverse, 0 into A inverse. A square into A inverse is A minus 5I plus 7A inverse is null matrix. What is 7A inverse? 5I minus A. What is 5 into I? 1001. What is A? A is 3, 1 minus 1, 2. So what happens now? 5005 minus 3, 1 minus 1, 2. This is what 7A inverse is. I continue further here. What is 7A inverse now? 5 minus 3, it is 2. 0 minus 1, minus 1. 0 minus of minus plus 1. 5 minus 2 is 3. What is A inverse? 1 by 7 into 2 minus 1, 1 2. This is what the inverse is. This is how we find out the inverse from a characteristic equation. I think you have understood this problem. Very simple. First we find out A squared, 5A, 7I. I have found and substituted in the equation to get a null matrix. Further, I have considered the same characteristic equation. I have multiplied throughout by A inverse. A square into A inverse minus 5A into A inverse plus 7I into A inverse is equal to 0 A inverse. A square into A inverse is A. A power 2 minus 1 A. A into A inverse, we know property, it is I. I into A inverse is A inverse. So 7A inverse is plus 5I minus A. I substituted for I, substituted for A and simplified and got the answer for A inverse. I think you have understood how we solve this problem. Let us take up the next one, 14th problem. For the matrix A, what is the matrix given? Matrix A, 3, 2, 1, 1. You have been asked to find the numbers A and B such that A square plus A into A plus B into I is equal to null matrix. It is given A square plus A into A plus B into I. Here you have to find out the unknowns A and B. See, let us find out A square. You know the regular method? A into A, it is A is 3, 2, 1, 1. A is again 3, 2, 1, 1. Multiply 9 plus 2. It is 11. 3 3s are 9, 2 plus 1. 3 2s are 6, 6 plus 2 it is 8. 3 plus 1 it's equal to 4. 2 plus 1 that's equal to 3. That's what A square is. Now what is A into A? A into A. A into A. A is 3, 2, 1, 1. So this becomes 3A, 2A, A and A. Now we have to find out BI. B into 1, 0, 0, 1, which will be B, 0, 0, B. Now what is given? Given the equation A square plus A into A plus B into I is equal to null matrix. What is A squared now? A squared is 11, 8, 4, 3. What is A into A? It is 3A, 2A and A. It is BI, B0, 0B is equal to null matrix. So what happens now? 11 plus 3A plus B, 8 plus 2A plus 0, 4 plus A plus 0, 3 plus A plus B is equal to, it is O, null matrix, 0, 0, 0, 0. Now you have to equate, let us equate 11 plus 3A plus B is equal to 0, 3A plus B is equal to minus 11. Now equate the second element there, 8 plus 2A 0, 2A is minus 8, and what is A? Minus 4. Got A as minus 4. Substitute the same value here, 3 into minus 4 plus B is equal to minus 11. Minus 12 plus B is equal to minus 11. What is the value of B now? Minus 11 plus 12. Value of B is equal to 1. B is 1 and A is equal to minus 4. Please understand the method. We have been asked to find out the two elements A and B. Given A square plus A into A plus B into I is equal to 0. First find out A square, then find out A into A, then find out B into I. Then you can simplify this. Think you have understood this problem? Next, 15. For the matrix A is given 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. This is what given. Prove that A cube minus 6A squared plus 5A plus 11I is equal to null matrix, and further you have to find A inverse. Hence is given find A inverse. What the question is. So A is 1, 1, 1, 1, 2, minus 3 and 2 minus 1, 3. You have to prove that A cube minus 6A squared plus 5A plus 11I is equal to 0, and hence find A inverse. Let us try to find out A cube, A squared first, then A cube. Let us find out A squared is A into A. What is A? 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. Let us take the product 1 plus 1 plus 2. 1 plus 1 plus 2 it is. First row, second column, 1 plus 2 minus 1. 1 plus 2 plus minus 1. First row, third column, 1 minus 3 plus 3. Think you have understood? 1 into 1, 1. 1 into minus 3, 1 into 3 is 3. Second row, 1 into 1, 1. 2 into 1, 2. Minus 3 into 2, minus 6. Now, it's 1 plus 4 plus 3. Next, 1 minus 6 minus 9. 1 into 1, 1. 2 into minus 3, minus 6. Minus 3 into 3, minus 9. Third row, 2 into 1, 2. Minus 1 plus 6. 2 minus 2 minus 3. Next, 2 plus 3 plus 9. Now check what is this. 4, 2, 1, 1 cancels 2, plus 3 minus 3 cancels 1, 1 plus 2, 3, 3 minus 6 is minus 3, 5 plus 3 it is 8, 1 minus 6 minus 9 it is minus 14, 6 plus 2, 8, 8 minus 1, 7, 2, 2 cancels it is minus 3, 2 plus 3, 5, 5 plus 9 it is 14. This is what A square is. Let us find out A cube. That is the important step now. Let us find out A cube. What is A cube now? A squared into A. What is A squared? 4, 2, 1. Minus 3, 8, minus 14. 7 minus 3, 14. This is what A squared is. What is A? Write down A. 1, 1, 1. 1, 2, minus 3. 2 minus 1 it is 3. think you have understood this. Let us multiply. Careful. 4 into 1, 4. 2 into 1, 2. 1 into 2, 2. First row, second column. 4 plus 4 minus 1. 4 plus 4 minus 1. Next. 4 minus 6 plus 3. Next. Second row. Minus 3 plus 8 minus 28. Minus 3 into 1 minus 3. 8 into 1 8. Minus 14 into 2 28. Next. Minus 3 into 1 minus 3. 8 2s are 16. Minus 14 into 1 plus 14. I think you have understood this. Next. Minus 3 into 1 minus 3. 8 into minus 3. Minus 24. Minus 14 into 3. Minus 42. Next. Third row. 7 into 1 7. Minus 3 plus 28. 7 minus 6. Then minus 14. Next. 7 into 1 7. Minus 3 into minus 3 plus 9. 14 3s are, it's plus 42. Let us see what happens to that 3 cross 3. That is A cube. 4 plus 2 plus 2. It is 8. 4 plus 4 8. 8 minus 1. It is 7. 4 plus 3 7. 7 minus 6. It is 1. Minus 3 plus 8 is 5. 5 minus 23. 5 minus 28. It is minus 23. 16 plus 14. It is 30. 30 minus 3 is 27. Next. Minus 3 minus 24. Minus 27. Minus 27 minus 42. It's minus 69. 7 minus 3 4. 28 plus 4. 28 plus 4 will be 32. 7 minus 6 1. 1 minus 14 minus 13. 7 plus 9 it is 16. 16 plus 42 it is 58. I think you have understood this. So this is, I think you have understood how to multiply this. You know the method of multiplication. Now you consider the LHS. A cube minus 6a square plus 5a plus 11i. I write a cube minus 6 into a square. What is that? 4 2 1 minus 3 8 minus 14 7 minus 3 14 plus 5 into a you want. A is 1 1 1 1 1 1 1 2 minus 3 2 minus 1 3 plus 11 into I 1 0 0 0 1 0 0 0 1. Now a cube I write. What is a cube now? 8 7 1 minus 23 27 and minus 69. It is 32 minus 13 is 58. Now multiply 6 to 8. 24 12 6 minus 18 48. It's minus 84. 14 6 are 7 6 are 42 minus 18. 14 6 are 84 plus it is 5 5 5 5 10 minus 15 10 minus 5 15 plus 11 0 0 0 11 0 0 0. That's what we have got. Now simplify. 8 minus 24 plus 5 plus 11. Next 7 plus 12 plus 5 plus 7 minus 12 plus 5 plus 0. Next 1 minus 6 plus 5 plus 0. First row is over. Take up the second row. Minus 23 plus 18 plus 5 plus 0. 27 minus 48 plus 10 plus 11. Now minus 69 plus 84 minus of minus 15 plus 0. It is 32 minus 42 plus 10 plus 0. Next minus 13 plus 18 minus 5 plus 0. Last 58 minus 84 plus 15 plus 11. Let us see what happens to here. So 5 plus 11, 16 plus 8, 24 minus 24, 0. 12 minus 12, 0. 5, 6 minus 6, 0. 18 plus 3, 23 minus 23, 0. 12 minus 12, 0. 84 minus 69 minus 15, 84 minus 84, 0. 42 minus 42, 0. 18 minus 18, 0. 58 plus 15, 73 plus 11, 84 minus 84, 0. I have got a null matrix. That's what the answer is. I think you have understood. A square first we found, then a cube, then you have found out a cube minus 6a square plus 5a plus 11i. Substituted and simplified, you have got the answer as null matrix. And they have asked one more problem there. You have to find out A inverse. How to find out A inverse now? See, very simple. You have been given, you have already proved a cube minus 6a square plus 5a plus 11i as null matrix. Multiply throughout by A inverse. A cube minus A cube into A inverse, 6a square into A inverse, 5a into A inverse plus 11i into A inverse and a 0 into A inverse. This becomes A square minus 6a plus 5i plus 11a inverse is equal to null matrix. 11a inverse is equal to, you will be getting 6a minus a square minus 5i. That's what you have to write. So 6 into a, what is a now? A is 1, 1, 1. 1, 2 minus 3. Then 2 minus 1, 3. What is a square? We have found a square. It is 4, 2, 1 minus 3, 8 minus 14. Then 7 minus 3, 14. Minus 5 into I, 1, 0, 0, 0, 1, 0, 0, 0. Now multiply 6, 6, 6. 6, 12 minus 18. 12 minus 6, 18. Next 4, 2, 1 minus 3, 8 minus 14. 7 minus 3, 14. Here 5, 0, 0, 0, 5, 0, 0, 0. We have understood. Simplify now. 6 minus 4, 2. 2 minus 5, it is minus 3. Next, 6 minus 2, 4. 4 minus 0, 0. 6 minus 1, 5. 6 minus of minus 3 plus 9. 12 minus 8 is 4. 4 minus 5 is minus 1. Minus 18 plus 14 is minus 4. Minus 4. Then 12 minus 7, 5. 5 minus 0, it is 5. Minus 6 plus 3 is minus 3. Minus 3 plus 0, minus 3. 18 minus 14, 4. 18 minus 14, 4. 4 minus 5 is minus 1. What is A inverse? 1 by 11 into minus 3, 4, 5. 9 minus 1 minus 4. 5 minus 3 minus 1. On the lengthiest problem, but we have to know how to solve this. So, I think we have understood all the problems which we have done today. Please solve these problems today, and tomorrow we will be solving some more problems. That's all for the day. Thank you.